Of the largest megascience-class installations that were created and functioned with the participation of the Russian Federation, but are located outside its borders, the most well-known installation is the Large Hadron Collider at CERN, where the Russian Federation has participated since the creation of this project. Both the elements of this accelerator and the subsystems of practically all main detectors designed to obtain physical findings have been produced in Russia. Russia also has several computer centers taking an active part in processing the data from the Large Hadron Collider. Another large facility is the International Thermonuclear Experimental Reactor. It was initiated by the Soviet Union, and its construction has already started in France. The actual project was initiated by a few countries, including the Soviet Union, as an international facility. The cost of the project is rather high. It is supposed to demonstrate the possibility of the peaceful utilization of thermonuclear reaction. It is also supposed to be one of the first reactors to start producing electric power through a thermonuclear reaction. Russia is also actively involved in many systems and subsystems of this unique facility. It is a cyclopean structure, a large superconducting solenoid, inside which super-strong magnets keep plasma at a temperature of several dozen million degrees Celsius. The energy extracted from the fusion of deuterium and tritium nuclei is eventually transformed into electric power. The other projects in which Russia takes an active part also involves the application of charged particle beams for the development of various technologies and research in other areas. Perhaps one of the most intellectually challenging and science-intensive projects is the project started in 2009 and officially commissioned last year in 2017. It is the European X-ray laser XFEL for short-wavelength laser light. What kind of facility is that? It's a 3.4-kilometer-long accelerator with superconducting resonators, the beam of which is used to generate coherent X-ray radiation. The intensity of the beam and the radiation characteristics enable it to be used for research in various areas. It makes it possible within a very short time and space resolution to obtain films of various processes with an atomic resolution in order to study new nanomaterial and the properties of biomolecules, with biomolecules not being isolated from the living organism, but within the living organism. The cost of this project, based on prices as of 2005, amounted to around 1.25 billion euros. Russia's contribution to the project was about 26% of the total cost. What is Russia's contribution? As an owner of the project, Russia may use the obtained X-ray radiation beams to carry out its own research. Under more or less the same conditions, Russia is also taking part in a project implemented in Germany. It is the Facility for Antiproton and Ion Research in Darmstadt. As part of the development of this project, 2 heavy ion accelerators are planned to be consecutively built for the implementation of the program of the fundamental research in 4 principal areas, as well as a broad program on the applied research in the utilization of high-energy heavy ion beams. Russia's contribution to this project is around 8% of its total cost.